So in this video, we'll deal with an example problem on Kirchhoff's current law. So this is the question given to us. Find the current in 3 ohms. So where is our 3 ohms resistor? This is our 3 ohms resistor. And we need to find the current in this particular resistor. So this is the circuit given to us. So this is a very complex circuit which was given with voltages. We are having 3 voltages here and 1, 2, 3, 4, 5 resistances given here. And they also gave us the currents, but these currents are unknown to us, right? So now first what we need to do, we need to identify all the junctions. So what is a junction? Where 3 or more branches meet is called a junction. So if we check here, this is a branch, this is a branch, and this is a branch. So this particular point is called as A, and the potential difference here is called as VA. Now if we are considering this particular branch, this is a branch, this is a branch, and this is a branch, and this particular point is called as B, and the potential difference here is called as VB. Now what we need to do, we need, next point is, this is the first point, and the next point is we need to assume initial voltage V0 is equal to 0. So this is our initial voltage and we need to assume it as 0. Now we need to assume, the third step is we need to assume the directions of the current, which means here they gave us I1, I2, and I3, I4, I5 and I6. The currents were given to us, but the direction of the current was not specified in the question. In that case, unknown current direction should be taken in the same direction. Means unknown currents should be taken in same direction. So, or it should be taken in outgoing direction. So this will make your problem easy if you are taking them in outgoing direction. So outgoing direction means what will happen? Your I1 flows this way, your I2 flows this way, your I3 also flows this way, and then your I5 flows this way, I4 this way, and I6 is from VB we are moving this side, so I6 goes this way. So these are the directions given to us. Now what we need to do, we need to apply KCL at each and every junction. So we are having 2 junctions A and B, for which we need to find out KCL equations for these 2 junctions. Now what is KCL? Sum of currents in the circuit is equal to 0, or sum of incoming current should be equal to sum of outgoing currents. Either of these two can be followed. Now, before finding the KCL equations, we don't know the values of I1, I2, I3, I4, I5 and I6. So, as we know, what is Ohm's law? Ohm's law is V is equal to IR, from which I will be V by R. So, using this particular formula, we will find currents I1, I2, I3, I4, I5 and I6. So this is the circuit we are having. Now what we need to find? Let me split the parts. First for junction A, and this will be for our junction B. So in junction A, which means in this particular junction you are having I1, I3 and I2 as the currents. So all these currents are moving in outgoing direction, right? So I2 is moving in outgoing direction, I3 and I1 are also moving in outgoing direction. So what will be your KCL equation here? I1 plus I2 plus I3 equal to 0 for junction A. If we consider junction B, so this is your junction B. So in junction B you are having I5, I4 and I6. So all these I4, I5 and I6. So this is your I4. So this is also moving in outgoing direction. This is moving in outgoing direction, and this is also moving in outgoing direction. So I4 plus I5 plus I6 is equal to 0. Why we are taking as positive is since all the currents are flowing in the same direction, you are taking it in the positive sign. So now if any of them is going in, suppose if you consider this I5, if it is going in incoming direction, then I5 will become negative. So it will be opposite, the sign will be opposite to outgoing direction. You just remember like that. So if first let us consider this case. Now in junction A, we need to find out I1, I2 and I3. How we will find out I1 first of all? So if we consider the case of I1, so this is the VA. So always current flows from higher potential to lower potential, means the current flows from this direction to this and it goes to V0. So first VA, next it is flowing in this direction and it is coming from positive to negative terminal. If our current is flowing from positive to negative, then we need to consider it as negative. If it is flowing from negative to positive, then we need to consider it as positive. So in this case, from VA, the current is flowing from positive to negative. So we take it as -6, and then it is going in this direction. So since it is a lower potential, we will take it as minus V0. This is our voltage. We are representing it in the form of V by R. So now what is our R? Our R is 6. So this will be our I1. Now what is our I2? This is our I2. So from VA, it is moving this in this direction. So VA minus, from here, from VA it is going to V0. So VA minus V0 by, what is the resistance we are having? 3. So this is our second equation. And what will be our I3? This is our I3. From VA it is moving to VB. So this current is moving from VA to VB. So VA will be our higher potential and VB will be our lower potential. Fine. If we are considering this particular case, when the current is moving from this direction to this direction, we are having a voltage here. And the current is flowing from negative to positive, which means you need to consider it as positive. So VA minus VB plus 5 by, and what is the resistance you are having? 2. So this will be your I3. This is the equation for junction A. Now if we consider for junction B, we need to calculate for I4. So our current I4 is moving from VB to VA and then it is going to V0. So VB will be our higher potential now. So VB, and VA is our lower potential, so it will be minus VA. Fine. And here we are having a voltage of 5 volts. So in this direction the current is moving. So it is moving from positive to negative. If it is from positive to negative, we need to take it as minus 5 by, and what is the resistance we are having here? 2 ohms. So this is our I4 equation. So now let's find for I5. For I5 it is moving from VB to V0. So VB to V0 means what? VB will be our higher potential and V0 will be our lower potential. And the resistance we are having here is 4. So VB minus V0 by 4. Next, for I6. So this is our I6. What is happening from VB? From VB the current is flowing through this direction. So VB will be our higher potential and it is coming in this direction to this point. So this is our V0. It is coming to this point. So VB minus V0. And now our current is moving from, this is the positive terminal and this is the negative terminal. So it is coming from positive to negative, means you need to consider as minus. So minus 10 by, and what is the resistance you are having here? 4. So this will be your junction B and junction A KCL equations. It's very easy if you are following the directions of the current properly. Now let us find out the KCL equation. So how you will find out the KCL equation for junction A and junction B? You will substitute I1, I2, I3 in these equations and I4, I5, I6 in this equation. Let's see. Now for junction A, we are having I1 plus I2 plus I3 is equal to 0. If we substitute VA minus 6 minus V0 by 6 plus I2 VA minus V0 by 3 plus VA minus VB plus 5 by 2 is equal to 0. If we take an LCM, we will be getting 6 as our LCM. So now what will happen? VA minus 6 minus V0 plus 3 2s are 6, so 2 VA minus 2 V0 and 2 3s are 6 plus 3 VA minus 3 VB plus 15 will be equal to 0. Now if we solve this part, we will get 2 VA, 3 VA, 2 VA, 3 VA, 3 VA plus 3 VA, 6 VA. 6 VA minus V0 minus 2 V0 minus 3 V0 and then minus 3 VB plus 15 minus 6 gives you plus 9 by 6 is equal to 0. Since V0 is equal to 0, if we substitute that in this part, you will get it as 0. So you will be remaining with 6 VA minus 3 VB plus 9 is equal to 0. If we are transposing this 9 this side, 6 VA minus 3 VB is equal to minus 9. And if we take 3 common here, 2 VA minus VB is equal to minus 3. So this is our equation 1 for junction A. In the same way, we will calculate for junction B also. So now let us see for junction B. So junction B is I4 plus I5 plus I6 is equal to 0. So what is our I4? VB minus VA minus 5 by 2 plus what is our I5? VB minus V0 by 4. And what is our I6? VB minus 10 minus V0 by 4 is equal to 0. Now if we are doing some math here, we will be getting our LCM as 4. So 2 2s are 4. 2 VB minus 2 VA minus 10 plus VB minus V0 plus VB minus 10 minus V0 is equal to 0. Now what will get? 2 VB plus VB plus VB. So automatically you will get here 4 VB and then minus 2 VA minus 10 minus 10 minus 20 minus V0 minus V0 minus 2 V0 is equal to 0. If this 4 goes this side, 0 into 4 is 0, so 0. Now if we substitute V0 is equal to 0, this part will become 0. So I'll get 4 VB minus 2 VA minus 20 is equal to 0. 4 VB minus 2 VA is equal to 20. If we are taking 2 common in this equation, we'll get 2 VB minus VA is equal to 10. So this is our second equation. So now what we need to do? We need to solve both equation 1 and 2. So solving 1 and 2, what we'll get? So first equation is 2 VA minus VB is equal to minus 3. This is our first equation. And 2 VB minus VA is equal to 10. This is our second equation. So how can we solve the equations? We can do substitution method. By solving system of linear equations, we learned it in our 9th and 10th standard grades. So by using those methods, you can solve. So let me use the elimination method. In elimination method, what we'll do? We'll match the coefficients for a variable. So in order to match the coefficients, we can do like this. If I am multiplying equation 2 by 2, so then what will I get? 2VA minus VB is equal to minus 3. And if I am multiplying this whole equation by 2, I'll get this as 4VB minus 2VA is equal to 20. And if I rewrite it in this form, I'll get it as minus 2VA plus 4VB is equal to 20. If I solve this equation, now what I'll get? Plus 2VA minus 2VA will be cancelled. 4VB minus VB, you'll get 3VB is equal to 17 and VB is equal to 17 by 3. Now put this VB is equal to 17 by 3 in any of the equations. I am substituting in first equation. If I substitute in first equation, what I'll get? 2VA minus 17 by 3 is equal to minus 3. 2VA is equal to 17 by 3 minus 3. This will be 8 by 3. And VA is equal to 4 by 3. So these are the values of VA and VB. So this is how you solve the problem for KCL. I hope you understood. And in the next video, we'll deal with another example.